Okay, this is the 2017 AP Calculus AB free response. So this is the actual test that was given in May of 2017. And we're going to work number 5 in this video. So the description in the problem is that you've got two particles. One is particle P, and the position of particle P is described by this equation, the natural log of t squared minus 2t plus 10. And then we have particle Q. They gave us the velocity equation for particle Q of t squared minus 8t plus 15. And the initial position is at time 0, x is equal to 5. So it asks us some questions concerning, we have to get me a new marker here, but part A says, when is particle P moving to the left? So what we need to do is figure out the velocity of particle P and see where it's negative. And where it's negative, it'll be moving to the left. So the velocity of particle P is going to be the derivative xp prime of t. So that's going to be 1 over t squared minus 2t plus 10 times the derivative of what we call in class the blob. So 2t minus 2. All right, so that's going to be 2t minus 2 over t squared minus 2t plus 10. And we want to set that equal to 0. Now, we're not really worried about where the denominator is negative. I'm really just going to worry about what is our critical point? Where is the numerator equal to 0? So let's just figure that out. Let's set 2t minus 2 equal to 0. Solve for t, and t is equal to 1. So we know it changes direction at 1. Okay, so if t is less than 1, the numerator is going to be negative. All right, so that's where it's going to be moving to the left. So the answer for this one is going to be between 0 and 1. All right, and that is when particle P is negative and moving left. Okay, so let's erase that and go on to part B. So part B says for between times 0 and 8, find all times t during which the two particles travel in the same direction. Okay, so first of all, we know particle P. Let me just kind of make a sign line here. We know that between 0 and 1, we just figured out that particle P is negative. And then when it's greater than 1, it's positive. So we'll refer back to that little sign line in a minute. Let's get the direction of particle Q. So we just want to set that equal to 0. So t squared minus 8t plus 15 is equal to 0. Let's factor that to find the critical points. Again, we just want to know about the velocity. Where's the velocity negative? Where is it positive? If it's negative, it's moving to the left. So we've got t, and then minus 5, minus 3. So our critical points are t is equal to 3 and 5. So let's make a sign line for particle Q. Right, 3 and 5. That goes all the way to 8. So a number between 0 and 3, I'll try 1. That would be a negative times a negative, which would be positive. Between 3 and 5, let's try 4. Negative times positive is negative. And then greater than 5 is going to make both those terms positive. So it's positive. So they're moving in the same direction where the signs of the velocity are the same. Well, between 1 and 8, so this one is between 1 and 3, this one's positive, Q is positive. So it would be, one of our intervals would be, let's see, 1 to 3. And then the other interval would be from 5 to 8. I guess we can put the less than or equal to sign on 8 since the original interval has less than or equal to there. Okay, so that's where they're both positive. Let's see if I can fit part C on the board here. Find the acceleration of particle Q at time t equals 2. Is the speed increasing, decreasing, or neither? Okay, so particle Q, to get acceleration, we're going to take the derivative. A of t is equal to v of q prime of t. So that's going to be 2t minus 8. So the acceleration, it asks for the acceleration at time t equals 2. So we just plug in 2, and that's going to be -4. So it also asks, is the speed increasing, decreasing, or neither? So what you want to know is if velocity and acceleration are the same sign, it's increasing. Otherwise, it's decreasing. So let's look at the velocity at 2. So we're just going to plug into the velocity equation. So that's going to be 2 squared minus 8 times 2 plus 15. So that's going to be 4 minus 16, negative 12 plus 15. That's 3. So the answer for that part, so acceleration, we want to circle that. It's -4. Velocity is 3, acceleration is -4. The answer will be decreasing, since they're going to want an explanation. Velocity and acceleration have different signs. All right, and let's go ahead and box that in so that the grader knows exactly what we're answering. All right, all those, in terms of the 2020 test, all 3 of those, A, B, and C, would definitely be a possibility because you're taking derivatives. The next one, part D, shouldn't be on the 2020 test because we're going to be integrating, but I'm going to go ahead and work the problem so that for your practice test that you can do those. And that new pen is hard to erase. All right. So let's look at part D. Part D says, find the position of particle Q the first time that it changes direction. Okay, so we know from part A that it changes direction for the first time at t equals 3. So that is just from part B. So to get what we call this problem calls it x. In class we call position S. All right, so S of Q, we're going to have to integrate V of Q. All right, so no problem. Let's integrate t squared minus 8t plus 15. Okay, and that's going to be 1/3 t cubed minus 4t squared plus 15t plus c. All right, so S of q is going to equal that. We got to figure out c. We know that x is equal to 5 when t is equal to 0. So if I plug 0 in for all three of these, I'm going to get 5. So c is just going to be 5. You can go through the math if you want on that, but I think this is one we can kind of eyeball. Since t is 0, it's pretty easy to figure out the position is 5 when t is 0. So c is going to be 5. So our equation is 1/3 t cubed minus 4t squared plus 15t plus 5. All right, so we want to know the position the first time it changes direction, which is at 3. So we're trying to figure out S of q of 3. So we're just going to plug 3 in for all those. So it's going to be 1/3 times 3 cubed minus 4 times 3 squared plus 15 times 3 plus 5. So I got to do a little bit of eyeballing. 3 cubes 27, not 9. 27 over 3 is going to be 9. 3 squared is 9 times 4 is 36. So 9 minus 36 plus 45 plus 5. So that's 50 minus 36 is 14 plus 9 is 23. So that's a really good problem, especially A, B, and C for the 2020 test, but for any other test, Part D is a really good problem. So I'll hit number 6 on the next one. We are going to skip number 4. I didn't think it was a really good problem overall to practice. Part A was, but the rest of it was pretty weird. So we'll just let that one go. So I'll see you at problem 6.